when the difference between each term in a sequence is always the same, then we have a linear or an arithmetic sequence. Now in example 1, we are given a sequence and we are required to show that the sequence is linear, which means we need to show that the difference between each term is the same. So by inspection, we can see that the difference between 87 and 91 is 4. In fact, the best way to think about it is, what do you have to add to 87 to get 91? And the answer is 4. And the same thing, what do you have to add to 91 to get 95? It's 4. So it's always, the sequence is going up in 4s. And here, what do you have to add to 95 to get 99? Again, it's 4. So 4 here is what we call the common difference. So this is what we call the common difference. And because the common difference between the terms is 4, then we can say that the sequence is linear. So the common difference between the terms is 4. And given that the common difference between the terms is 4, it implies that the sequence is linear. Okay, remember the definition for a linear sequence is that the difference between each term in a sequence is always the same. Okay, so once we've shown that, then we can generalize that the sequence is linear. Now, in the next case, we can again see that the sequence is descending, which means to get the next term, you have to subtract 4 from the previous term. So this is minus 4, minus 4, minus 4. And again, minus 4 here is what's called the common difference. And we can see that the common difference between the terms is negative 4. And therefore, the sequence is linear. Okay? Because again, from the definition, the difference for any linear sequence, the difference between each term in a sequence is always the same. Okay. Next, let's look at the nth term of a linear sequence. So the position to term rule. How do we find the position to term rule of a linear sequence? So think about the sequence that you're given here: 7, 10, 13, 16, and 19. How can we be able to find the nth term or the position to term rule for this sequence? The first step is, of course, to find the differences between these terms, and we can see that the difference here is 3. Okay. Now, what does this mean? It means that there has to be a connection between multiples of 3 and this sequence. Yeah? So there has to be a connection between multiples of 3 and this sequence. And just so to remind you about the positions, this is the first position, that's the second, that's the third position, fourth position, fifth position, and so on and so forth. So what I'm going to do to help you observe what I want you to see here, I'm going to represent the sequences in a table. So, and in that table, we want to look at 3 things: the position of this of the terms in this sequence. We want, like I said, there has to be a connection between the multiples of 3 and this sequence. So we are going to represent that in the table again, and the terms of this sequence. So suppose we draw a table like this one here, and we plugged in first of all the sequences, the sequence that we have here, and the sequence that we have here is 7, 10, 13, 16, 19, and so on. So, you know, this goes on and on and on. And multiples of 3 will be just 3, 6, because 3 multiplied by 1 is 3, 3 multiplied by 2 is 6, 3 multiplied by 3, 9, 12, 15, and so on. And then the positions. The position, of course, 7, that will be the first position. So here we have the first position, second position, third, fourth, and fifth. I meant to write fifth there. So fourth and fifth. Okay? But of course, what you're interested here is to find the nth term. Okay? So the nth position. For the nth position, what will be the formula? What will be the formula that you can use to find any term in this sequence? Anyway, so by inspection, we can see that if you are given the multiples of 3, to get these terms, you have to add 4 to each of these. You have to add 4 to multiples of 3 to get each term in this sequence. So for example, here you add 4, you get 7. You add 4, you get 10. You add 4, you get 13. You add 4, you get 16, sorry. You add 4, and you get 19. Now, we know that the multiples of 3 will be represented by 3n. So this will be 3n, just 3n, because 3 multiplied by any position, then you get any multiple that corresponds to that position. And what you're saying is that for you to get these terms, you have to add 4 to multiples of 3, which means that the corresponding formula here will be 3n plus 4. Now, that is what we call the nth term, or the position to term rule for a linear sequence. Okay? So we can say that the nth term for this sequence is 3n plus 4. And that's how you can find the nth term of a linear sequence. Okay, let's look at the next example. Find the nth term of this sequence. So the first step is, of course, to find the common difference between these terms. And we can see that the common difference is minus 2. And of course, this is the first term, second term, third term, fourth term, and fifth term, and so on. But what we want to find is the nth term. So what we can do is to represent this sequence in a table. So we have the positions, and here we are going to compare with multiples of -2, because the common difference is -2. And of course, we have the terms. So if we represent this in a table, then we have, of course, the first, second term, third term, fourth term, fifth term. And what we want, in fact, what you're interested in this process is the nth term. So, what are the multiples of negative 2. Negative 2 multiplied by 1 will be um, negative 2. Negative 2 multiplied by 2, negative 4, negative 6, negative 8, negative 10, and so on. So negative 2n. Negative 2 multiplied by the position. And then the terms that we are given in this sequence are, we have negative 5, negative 7, negative 5, negative 7, negative 9, negative 11, negative 13. So the nth term here can be found by inspection. So if we look at the multiples of negative 2 and the terms are given, we can see that if you're given any multiple of 2, to get the corresponding term, you subtract 3. So in each case, you subtract 3 to get the corresponding term from the multiple of 2. So which means the formula here will be negative 2n minus 3. And this is what we call the nth term. Okay, so that's the position to term rule. You can use it to find any term in this sequence. So we can say that the nth term of this sequence is minus 2n minus 3.